Hello, this is section 1.5. This time we're going to solve quadratic equations using the quadratic formula. So you can solve a quadratic equation by factoring, but what if it doesn't factor? Well, then you can use the quadratic formula, and the quadratic formula is this. If you have your quadratic equation set to this form, ax squared plus bx plus c equals 0, then you can solve for x by setting x equal to negative b plus or minus the square root of b squared minus 4a times c all over 2a. Right? So we have learned about complex numbers. We know that you can have imaginary numbers. So now we're moving into a possibility of having solutions that aren't real. Instead of saying no solution, we can give you some non-real solutions. All right, so this leads us to being able to tell what kind of solutions we're going to have if we look at the discriminant. Now, the discriminant is the expression underneath the radical, b squared minus 4ac. And the reason that this tells you what the nature of the roots are, or solutions, is because of where it's located. It's underneath the square root, and there's a plus or minus. So that discriminant will tell you everything you need to know about the roots. So if we calculate b squared minus 4ac and we get 0, then think about it. It's going to be the square root of 0, which is 0, which is a real number, and the plus or minus of 0 doesn't give you two different answers. So if you get a discriminant of 0, you're going to have one, what we call double root, because you're just going to have one root. Now I'll go ahead and let the cat out of the bag. The degree is 2. So when you have a degree of 2, you should expect two solutions. Now we don't like exceptions to the rules that we have in math. So if you get one solution, we call it a double root because the 0 has a multiplicity of 2. So if you account for multiplicity, if you have a degree 2, you're going to have two solutions. Even though it's one solution, it's multiplicity 2. All right, so if you have a discriminant of 0, you'll be able to tell that you'll have one double root, and that'll be a real and a rational root. Because again, the square root goes away. So that means it will be rational. Okay, what do I mean by rational? Well, it might be irrational. So if you evaluate b squared minus 4ac and you get a positive number that's not a perfect square, it's all about location. So if you get something like 37 underneath that radical right there, then the square root of 37 is an irrational number. And the plus square root of 37 and the minus square root of 37 are going to give you two irrational roots. They're real because the square root of 37 is a real irrational number. So if you have a positive number that's not a perfect square, that's going to give you two real irrational roots. It's all about where that b squared minus 4ac is. Let's look at this one. If you get a positive number that is a perfect square, let's say you do b squared minus 4ac and you get 9. Because of the location under the radical, the square root of 9 is 3. So that means it's going to be rational. And plus 3 and minus 3 are going to give you two different answers. So if you have a square, perfect square underneath the radical, you're going to get two real rational roots. And what that means is you could have factored that quadratic to solve in that way. All right, in the last situation, we've learned about complex numbers. We know that the square root of -1 is equal to I. So if you evaluate b squared minus 4ac and you get a negative number under the radical, when you have a square root of a -4, you have to pull an I out. If you have a square root of -7, you have to pull an I out. So plus or minus is going to give you 2. But their roots are going to be imaginary roots. Okay? So you can quickly discern whether a quadratic, what type of root you're going to have. Now, I use this all the time when I'm trying to figure out if something factors or not. If I put the discriminant in and I get a perfect square, then I know, oh, it factors. Let me see if I can factor it. If I put b squared minus 4ac in and get a non-perfect square, then I know, okay, this isn't going to factor. I got to use the quadratic formula. Okay, so we can use the quadratic formula, and you can not do all of this and just solve and see what you get. That would be an option too. All right, so let's do 3 examples here. So when you have a quadratic, first thing you want to notice is the m squared. So once you see you have a degree 2, and once you see that you have an m squared and an m, then you're going to want to get your quadratic in this form: ax squared plus bx plus c equals 0. Okay, because you can't use a quadratic formula until it equals 0. So I'm going to move this negative 10 over by adding 10. And so 2m squared minus 7m minus 13 plus 10 is minus 3 equals 0. Okay, so now I'm just going to go ahead. The quadratic formula works 100% of the time, so I'm not even going to see if it factors. So I'm going to say m equals, and it's negative b, or opposite of b, times the square root of, now watch what I'm going to do here, parentheses b quantity squared minus 4ac, all over 2a. Now I've started writing it this way for students because if b is negative, it can get people in trouble. So I'll show you what I mean. So m equals negative b. Well, a is 2, b is negative 7, and c is negative 3. So I have to put those numbers in. So if b is negative 7, then the opposite of b is positive 7. That just means opposite of b. So 7 plus or minus the square root of b. This is what people do sometimes. They'll do this. Now, if you do that and you put it in the calculator like we're going to, you're going to get the wrong answer. You really want to remember that when you square a negative, you have to put parentheses around it in the calculator. So that's parentheses negative 7 squared minus 4 times a, which is 2, times c, which is negative 3, all over 2 times a, which is 2 times 2. All right, now we want to show our work. So we want to make sure that we show this step here. I don't put the square root in the calculator. What I want you to do, and what I do, is I'd write 7 plus or minus square root symbol. Put my pencil down, and now I'm going to put the discriminant in, which is what's underneath the radical. And remember, you have to put parentheses around that negative 7 when you square it. I know that's positive 49. If you don't put parentheses, your calculator is going to calculate it as negative 49. So minus 4, parentheses 2, parentheses negative 3. So the value under the radical, the discriminant, is 73. So I've already written down all of it. 7 plus or minus square root of 73 all over 4. Okay, then what you would have to do is try to simplify this. But square root of 73, 73 is prime, so you're done. And you want to try to simplify the coefficients. There's nothing that goes into the 7 and the 1 and the 4, so that's it. So those are your 2 solutions. Those are 2 real, irrational, when you have a square root that doesn't go away, roots. That's what m equals. All right, so 7 plus the square root of 73 is approximately 3.88600000936. So you don't want to write that. You want to leave your answer exact. But if you were graphing, you could graph that. It's approximately 3.9. And then 7 minus the square root of 73 all over 4 is approximately negative 0.386. So you could graph those. Those are x-intercepts. Those are called zeros. Those are called solutions. All right, so let's try another one. Again, you have a quadratic. I know it's quadratic because of the n squared. And I know that I can't solve it using traditional algebra because there's an n squared term and an n term. So what you're going to want to do is get it into ax squared plus bx plus c equals 0 form. So we've got to move this term and this term from the right to the left, but we want to make sure it's in descending order. So I want to write the 9n squared first, and then that 7n becomes minus 7n, and that 4 becomes minus 4. So these two move from the right side to the left side, so the sign's changed. And so we're going to put it into the quadratic formula. N equals negative b plus or minus square root parentheses b squared minus 4ac all over 2a. What I'm doing is modeling for you how I memorize things. I just keep writing the formula over and over again. So now let's put it in. N equals negative b. So we got to look right here. A is 9 and b is negative 7 and c is negative 4. So negative b means opposite of b, so that would be positive 7, and then plus or minus square root of parentheses negative 7 squared minus 4 times a, which is 9, times c, which is negative 4, all over 2 times 9. So then I'm going to write down 7 plus or minus square root because I have to show my work. Then I pick up my calculator and I'm going to put the discriminant in, which is the value underneath the radical. So parentheses negative 7 quantity squared minus 4 times 9 times negative 4. And I'm going to get another square root that looks like you can't simplify that over 18. It's odd, so 2 doesn't go into it. If you add up the digits, 1 plus 9 plus 3, you get 13. If you get something that 3 goes into, then that means 3 goes into 193. So nothing goes into 193. I'm fairly certain that that is prime. So again, we're done. So again, you have 2 irrational roots. Those are the solutions. All right, let's try the third one. So if we have 5x squared plus 3x plus 1, x, when I solve using the quadratic formula, it's going to equal negative b, which would be negative 3, plus or minus the square root of 3, quantity squared minus 4, times 5, times 1, all over 2 times 5. So x equals negative 3 plus or minus square root. Put your pencil down. Let's figure out what that discriminant is. So that would be parentheses 3 squared minus 4 times 5 times 1. Ooh, this time we get negative 11 as our discriminant. So finally we have something different going on here. So x equals negative 3 plus or minus I square root of 11. So when you have a negative under a radical, you have to pull out the I all over 10. Then we want to check the coefficients to see if they reduce. And nothing goes into negative 3, 1, and 10. So that's it. So you get these two solutions. That's 2 imaginary roots or solutions. Now, let's talk about what's going to happen there. When these two happen, these are real irrational roots, so they are going to cross the x-axis somewhere. All right? But these, when you get two imaginary roots, we know that that parabola opens up. What's happening is that parabola is not crossing the x-axis. All right, I'm going to pause the video because really you just need to practice. And so when we come back, you'll see some answers. And if there's something different that happens, I'll talk about those. Okay, it didn't take me long, so I'm going to stop at 4. when you move that minus 125 and get plus 125, did you notice that 5 went into all of those? You can divide out the greatest common factor here. So that's a good idea. So 5 goes into all of those. So I can divide this side by 5 and that side by 5. And that gives me x squared plus 10x plus 125 divided by 5 is 25. And so the smaller the numbers, the easier it gets. So that's what I'm going to do for that one. Okay, so a couple of interesting things happened here. So when you continue with this one, did you get that your discriminant or the value underneath the radical was 0? Well, that means you have to keep going. So negative 10 plus or minus 0 is negative 10 over 2, and so that reduces to negative 5. So what's going on there is two things. This would have factored, and indeed it does. It factors into x plus 5 times x plus 5, or x plus 5 quantity squared equals 0. So you get one root, and that's called a double root because the multiplicity is 2. That means you just count it twice. So that's interesting. All right, if you did number 5, what's going on here is you end up with the square root of 80 under the radical. So this is the first time we have to simplify this. We can't just leave it this way. So square root of 80, your calculator will simplify, but there is a perfect square in there, but your calculator will do it. So if you put in the square root of 80, it's going to simplify it to 4 square root of 5, see? So we have negative 8 plus or minus 4 square root of 5 over 8. All right, that leads us to the next piece of the simplification. You have to check to see what goes into all three of these coefficients, the negative 8, 4, not the square root of 5, but the 4 and the 8. And you see that 4 goes into those three things. So what you need to do is divide the top by 4 and the bottom by 4, which is not easy, which is legal because that's 1. And so negative 8 divided by 4 is negative 2. And 4 square root of 5 divided by 4 is just 1 square root of 5. And then 8 divided by 4 is 2. So you have to simplify your answer. So that's interesting about that one. And then same thing happened over here, except you ended up with a negative under the radical. So you pull an I out, that gives you I squared of 12. Well, you can use your calculator. The square root of 12 is 2 square root of 3. So this simplifies to 6 plus or minus 2i square root of 3 over 2. Well, notice the 6 and the 2 and the 2. 2 goes into both, all three of those. So you have to divide that out. So that reduces to 3 plus 1i square root of 3 over 1, which I didn't bother to put because anything over 1 is just the numerator. Let's see what happens on the problems on the back. So try these, and I'll come back and if anything interesting has happened, we'll talk. Okay, so this one is an interesting one. So I paused. Let's talk about it. So first you move the negative 7 over. You get 2k squared plus 9k plus 7 equals 0. And then you put it in the quadratic formula. So you get k equals negative 9 plus or minus the square root of 81 minus 4 times 2 times 7 all over 2 times a, which is 2. So then you get negative 9 plus or minus square root, and then when you put that under the radical, you should have gotten a 25. So all over 4. So now you can keep going. The square root of 25 is just 5. So when this happens, when the radical goes away, you can't stop here. You have to keep going. So what does this mean? So negative 9 plus or minus 5 all over 4 means negative 9 plus 5 all over 4. Or negative 9 minus 5 all over 4. Okay, so once you do that, well, you can simplify that. That's negative 4 over 4, negative 1. 14 over 4, which is negative 7 over 2. So you get two rational roots here, which means you could have factored this. So if we go back to the beginning, we factor this. The factors of 2 are 2k and 1k. And the factors of 7, they have to, the outer and inner terms have to add it to 9, so that would be 7 and 1, and they both be positive. And so you can see that if you were to set this equal to 0, you would get negative 7 halves. And if you were to set, I wrote negative 2, I meant negative 1. If you were to solve this, you would get k equals negative 1. So these roots tell me that I could have factored it. So what that leads to is that the quadratic formula can be used 100% of the time to solve a quadratic equation. Let's keep going. Let's go ahead and keep it rolling here. I'll do this one with you. Just notice that this is still quadratic, okay? It's still quadratic, but what's missing, it's missing the bx term. So you only have one x. So I wouldn't use the quadratic formula here. I would just use traditional algebra. How do you undo multiplication of 5? Well, you divide by 5. And so that's going to give you r squared equals, what's 80 divided by 5? 16. So you can undo that square by square rooting. And when you take the square root, it's plus or minus 4. So when you're missing the bx term, I wouldn't use the quadratic formula. I would just use traditional algebra to solve it. Okay, I'll pause it and reveal the answers for the. Okay, so for 9, I got the square root of 289 underneath that radical. That's the discriminant. So it ends up being 1 plus or minus 17 over 4. Remember, you have to keep going. And I ended up with 9 halves and negative 4 is what x equals. That means that would have factored. All right, but number 10, I ended up with a negative 220 as my discriminant. So I pulled the I out, and then the square root of 220, I put it in the calculator. That's 2 square root of 55. So this is 2i square root of 55 over 14. So we got negative 2 plus or minus 2i square root of 55 all over 14. Well, then I noticed that the negative 2 and the 2 and the 14 can all be reduced by a factor of 2. So I divided by 2 in the top and the bottom, and I got negative 1 plus or minus I square root of 55 all over 7. So I get 2 imaginary roots here. So that would not have factored. And if you were to graph this, the quadratic would not have touched the x-axis. If you were to graph this one, the quadratic's going to cross through negative 4 and 4.5. So these solutions are called roots. They're called zeros because you set it equal to 0. They're called solutions. They're called x-intercepts. These are called solutions. They're called roots. They're called zeros, but they're not called x-intercepts because only real numbers show up on the x-axis. All right, so that's the lesson for solving with the quadratic formula.